Afternoon, I'm going to show a little video on how we can use our calculators to solve these out. I think if we show one example of how the calculator works, it can really make some of these problems really quite more interesting. So, in a sense, we have two large stones, one shot up upwards at 30, and the other one is shot up at 32 seconds later. So one is going up, and it's going up at 30 meters per second. And then a few seconds later, when this one's up here, this one starts to come back down, or maybe it's still on the way up, but another one is being shot up. So at some point, they're going to cross. Okay. So where and how fast is A going at the second second? Okay. So I'm going to walk through this entire sort of problem here, and we're going to do a little bit of work as far as this stuff goes here. Non-calculator based or non-graphing based. So in this case, where is A after 2 seconds? So I want to know the location of A at 2 seconds. Okay, so there we go. And we have, in this case, the location at a certain time. It started out at 0 point, and it's exiting up northbound at 30 t. And then at this point, it has an acceleration of negative 4.9. Well, I could get a little more specific there. T 1/2 9.8, okay, which is the 4.9 t squared. So I want to know at what point, or where am I at this point here. So grab your quadratic formula, and it will tell me my location at the 2 second mark. Actually, I don't need the quadratic. I'm going to put 2 seconds in here. So we'll put 2 in here, and we'll put 2 in here, and let's go ahead and solve this out. So we have 30 times 2 is 60, and then this is a negative value, so it's going to be 0.5 times 9.8, which is the negative 4.9, times 2 squared, which is 4, and that gives me 19.6, and this is negative. Okay, all right, minus or take away from the 60, and I am at xt equals 40. So that's where this guy is 40 meters up in the air when this guy is sort of launched. Okay, now, what's the velocity of this guy at that 2 second mark? So velocity initial plus AT. The velocity initial is 30. And I have a negative acceleration of 9.8. It's 2 seconds later. You could do 10 if you like. In fact, I'll probably just do 10, which is going to be 20. And negative 20 plus 30, which means I still have a positive velocity of 10. Okay. All right, so let's start setting up what's going on here. At what time and how high will the crossing go? So I'm going to set my sort of overtake situation where I have the first rock and I have the second rock. Okay, and I'm going to reference this off of the time the second rock is launched. So x0 plus VIT plus 1/2 AT squared equals, and then I have x0 plus VIT plus 1/2 AT squared. Now, the first rock is no longer on the bottom. It is at position 40. Its velocity is 10. And it has a negative 4.9 t squared equals, where is this next guy going to be? Well, it's at the 0 point. It still has a velocity now of 30 t, and then plus a negative 4.9 t squared. So for our purposes, we were going to want to have a situation where we're just going to be solving for t. Now, mathematically, because our 4.9s are the same on both sides, I'm going to cancel those out, and I can simply solve for this guy. That's going to be 40 equals, subtract the 10t over, that's going to be minus 10t, gives me 20t. divide out the 20, and divide out the 20. And there we go. Looks like t equals, looks like what, 2 seconds. Okay, now that's the math part. Now the 2 seconds you could just sub into anywhere you want. Now the first rock has already been in the air for 2 seconds. Okay, so this guy's been in the air 4 seconds. I might just go plug it into here and see where this guy is when 2 seconds shows up. And then they're both at the same spot. Now let's take a moment and let's see how we might graph this guy out here. So I have this little graphing calculator here, and I'm going to put both of these guys in here under the individual graphing. So the first one, all right, so let's do rock number 1. So the first thing, it's at 40, so type in 40, and then plus 10t is going up, 10, and then this button right here just gives us a variable, and then plus, now you could do a negative if you want, but I'll go negative 4.9, that's this guy right here, and then x squared, okay, and then this one below here is going to be just this guy, which is just 30x plus a negative. Now that if you use that as a negative, it doesn't work, it's an error, just so you know. I could take out that guy and put a negative subtraction in there, but either way, and it's going to be x, variable x, and then we'll square it. And I missed my 4.9. Let's delete. Okay. 4.9. Seems it might be better to start over. Negative. Negative 4.9 x squared. Is it correct? Lots of places to make mistakes here. Okay? And we'll find out soon. Let's graph this thing. And get, there we go. And let's see here. So first one. So it didn't like that. Let's go to here. What do you like? Oh, no subtraction there somehow. Alright, let's delete that. Alright, let's graph it out. And so we got there's our first one. And then there's our next one. Slow, but it's there. Now, again, the blue one is the first one launched. So now, since I made my reference point off the second one, it's at 0. And you could zoom. And let's go zoom in a little bit here so you can see a little more. Okay. And hold on for 1 second here. Okay, so if we want at this point to sketch our graph out, we can do that. Okay, our graph's not the hardest to sketch out. I'm going to take and just mimic what I'm doing right here. And I notice that I'm going to draw out my little guy here, and I'll bring it back up here. It's going to go away for a second here, but let's grab my pen. And I'm going to sort of sketch this thing out here and cut across. Okay. At that point, I could do one color. Now again, from here, depends how you want to do it. You just start your frame of reference from 0, then it's going to look something like this. Okay. And of course, the computer doesn't know that it hit the ground. So, with that being said, this next guy, the Y is position, and it's only doing the up and down. So the T is then eventually the time, and this is the slope of this is the velocity. So 2 seconds later, I get this guy, and it's going to be identical to the other one. It's just offset a little bit. Okay, and there we go. So that's the point where they're intersecting, and that's at this time. So this is not the scale time. Let's go back to our graph and see if we can figure out the time. Okay, now what we do here for this is we go second, and we go calculate. and I want to do intersect number 5, or the intersect. And it's going to ask you a couple questions here. All right. Should have a couple questions. So first curve. There's 3 questions. I just will enter for all of them. First curve, second curve, and then one estimate where they're at. And there it goes. So just hit enter 3 times. And it's telling me that 2 and 40. So that means it's intersecting at 2 seconds and at height of 40 meters. Okay. So at this point, this is looking pretty good right here. Okay. And at that point, you can also have your time as well. My graph is not to scale. I'm just going to do one problem. I think with this particular idea of using the graphing calculator, you should be able to run the next problem, number 3, verify your work as well. Thank you very much.